Okay, in this video I'm going to go through um, one of the problems. I think we worked on this in class on Wednesday. The first thing I want to do is find an expression for the slope of the curve at any point xy. That's the slope of the curve is dy dx. So I'm going to do implicit differentiation and take the derivative of both sides with respect to x. The derivative of x is 1. The derivative of xy is 1 d2 plus 2 d1. That's x y prime plus y. And the derivative of 2y squared, is 4y y prime. And then the derivative of 6 is 0. What I want to do next is to group my y primes, move everything else over. So on the left side I'll have x y prime plus 4y y prime, and on the right side I will have negative 1 minus y. I'm going to factor out a y prime from the left side, and that leaves me x plus 4y. I'm going to divide both sides by x plus 4y, and that leaves me y prime is equal to negative 1 minus y over x plus 4y. The next thing that we want to do is to write an equation for the tangent line to the curve at the point 2, 1. And for the equation of a tangent line, I need a slope, I need an x-coordinate, and I need a y-coordinate. In this case, my x-coordinate is 2, y-coordinate is 1. And my slope, which I will get from y prime, is negative 1 minus y, so it's negative 1 minus 1, which is negative 2. And x, which is 2 plus 4y, so negative 2 over 6, which is negative 1/3. And recall I found that just by substituting x equals 2, y equals 1 into my derivative formula. And now I'm ready to find the equation of that tangent line. And I start plugging in. y1 is 1, m is negative 1/3, x1 is 2, and that is sufficient. That is an equation of the line tangent to the curve at the point 2, 1. Doesn't necessarily have to be in y equals form. Alright, so the next thing we want to do is to find the coordinates of all other points on this curve with slope equal to the slope at 2, 1. And I'm going to scroll down so we'll have some more space. Now, the way that we're going to go about doing this, let me just set up the problem first of all. I want all other points on the curve with a slope equal to the slope at 2, 1. Well, we know the slope at 2, 1 is negative 1/3. So I want to find all the other points where the slope equals 1/3. So I'm going to take the derivative, set that equal to negative 1/3, and then I'm going to begin to solve. So I will take that and move it on to the next screen, and we'll work on it from there. And we're going to solve this. Probably better resolve the negative signs first. So I'm going to factor out a negative 1 from the left numerator, and then I'm going to cancel my negatives. Alright, that'll make the process a little bit cleaner. And now I can cross multiply, and I get 3 times 1 plus y is equal to x plus 4y. So 3 plus 3y equals x plus 4y. I can excuse me, I collect the y's on one side, x's on the other, and so we get the relationship that y is equal to 3 minus x. What this tells me is that on the graph, at any point where the y-coordinate is 3 equal to 3 minus the x-coordinate, then at that point the curve will have a slope of negative 1/3. So how will we find those places using this information here? Well, we're going to take that y equals 3 minus x and substitute for y in the original, and that should yield us only the places that meet this particular criteria. So I need the original function. So recall the original expression is x plus xy plus 2y squared equals 6. In place of y, we substitute 3 minus x. We combine some like terms, multiply things out, and continue that process. And eventually we come down to x squared minus 8x plus 12, and that gives us the two values x equals 2, x equals 6. We only need to go back to this equation y equals 3 minus x, and that gives us the 2 points 2, 1 and 6, negative 3. You can test those back in the